Hello, my name is Dr. Adrian Leek. I have a PhD in Colour in Relation to Computer-Aided Printed Textile Design. This is my second short talk about colour fidelity. I'll be covering how printers and monitors' colour spaces are managed professionally, how designers can work with bureaus, and also lay out an easy workaround that all designers and artists can adopt to try and improve colour fidelity. In the last talk, I discussed how printers, cmyk subtractive optically mixed colour spaces, are formed, and how they relate to all the colours we see by placing their gamuts against a CIE LAB colour space. I also explained how monitors created their colour space using RGB primaries, and how their gamuts related to all the colours we can see by once again placing them against the full CIE spectrum. By overlapping the two devices' gamuts on the CIE spectrum, it is easy to see the problems. While monitors can display a lot of the colours a printer can print, it shows how limited the colour space of a printer is, and that some colours that can be printed cannot be shown on the monitor, especially the dull matte colours. Also covered in the last talk were the things that can affect both these colour spaces, such as diver patterns, viewing angles, and resolution. It also explained that while it was impossible to completely fix colour fidelity issues, there were some things that can be done to help. The professional way is to calibrate devices and to work in a shared colour space. With monitors, you need to ensure all the monitors are set at a consistent angle and the ambient lighting is controlled. To calibrate the monitor, a palette of colours is displayed on the screen, then using a spectrophotometer, you read these colours back into the computer so that it knows how the monitor's colour space compares to the CIE colour space. Printers are calibrated in the same way. A palette of colours are printed, choosing the resolution, diver pattern, and the media you want to print on, and as with monitors, a spectrophotometer is then used to read those colours back into the computer so it knows the colour space of the printer against the CIE colour space. Once a computer knows the colour spaces or colour profiles of the devices by the calibration process, design packages such as Photoshop can then use this knowledge to fairly accurately give an out-of-gamut warning if a colour is displayed on the monitor that can't be printed. It can also use this knowledge to manipulate the colours in a file in a number of ways. It can lock the colour spaces, but this can cause out-of-gamut colours on the edge of a colour space to be printed using a single colour, which can cause subtle shading to be represented by just a single colour that can cause banding. Alternatively, it can manipulate all the colours in a file so that while there is no banding, it will alter all the colours in the design. This approach tends to be good for photographs, but for textile or graphic design where particular colours are critical, it can cause problems. A nonlinear manipulation can also be used that will not alter all the colours, but only those near or on the edge of a colour space. The calibration process, while massively improving colour fidelity, can still not fix all the problems as you are trying to match two different ways of creating colour, i.e. monitors using light and printers using ink. This approach is also very costly, not only in terms of time but in the costs of the hardware needed to calibrate devices, and it can also affect how a designer works. This approach is more for covering up a finished design for mass production rather than for designing. A more common way of working is with a bureau or printing firm. While most designers can afford a computer and monitor, a large format production printer is normally out of their budget. Therefore, files tend to be sent to bureaus to print. If working with a bureau, you need to get an ICC color profile off them for the printer they're using for production. This is the file created after a printer has been calibrated. You can then import this profile into programs like Photoshop so that you can work knowing what is within your bureau's printer's gamut. However, as your monitors won't be calibrated, it will not be as accurate as a fully calibrated workflow. Therefore, you'll also need to check with the bureau to find the monitor's color profile they prefer files arrive in. Common ones are sRGB or Adobe RGB. You can then choose the correct RGB profile when creating a new file or when importing files into a design program. Another way of working is to use a lookup table, such as a Pantone color book, and share the Pantone colors designations with your printing bureau. This is especially useful when using spot colors that are critical or using metallics. The bureau might also be able to give you a palette of colors that its printer can print, sometimes called a blanket, and again you can choose colors from that, knowing how they will look when printed. But of course, working with lookup books or color atlas, while okay for flat color designs of several colors, is obviously no good for photographic work or illustrations with thousands of colours. Nevertheless, understanding terms such as gamuts, ICC profiles, and knowing how devices create colour will enable you to build a better working relationship with your chosen bureau. Rather than with calibrated workflows or with bureaus, it is more common for designers to work using their own uncalibrated monitor and printer. I suggest a simple way of managing colour flow is in the following way. Essentially, it's about building up a working knowledge of how your monitor and printer work together. Once you have created and printed a design, you create a file of the same resolution as your finished design to the size of your printer's print size, normally A4 or A3. You can then build a palette of the colours used in the design, creating squares about 1 and 1.5 centimeters in size for each colour. When you've done this, you can copy and paste that palette as many times as you can fit on your page. Now, leaving the first palette as is, you select each of the other palettes in turn, and using the colour tools in your software, you can modify each palette. I tend to modify the saturation by 25%, another palette I might alter the contrast, another the lightness, etc. When you print these palettes, you can then see how close you can get to the colours in the final design as seen on the monitor. You might find a saturated colour is a closer match than the printer's original print of your design. And as each colour has its own coordinates, either cmyk, HSB, RGB, LAB, you can use these coordinates to recolour your design. Working this way, you start to build up knowledge of how your printer prints. You'll also begin to build a library of palettes and find favourite colour combinations that you can start to use to colour designs. Don't forget, colour effects still work on digital as well as printed images. In the design I showed, some colours are surrounded by other colours, therefore they'll be affected by simultaneous contrast. So it might be an idea to build a palette that reflects that, such as this. That way, the proportions of the colours are also taken into consideration. Managing colour in this way, I think, is more in tune with how designers work. The joy of working digitally is accessing such a wonderful array of colours. As David Hockney noted, it's like painting with stained glass. If you work to a restricted palette from the start, it can be off-putting and can interfere with the working process. I find it's better to design normally than worry about how a design will print later. Also, as you build a more detailed understanding of how colour fidelity works in your working process, you'll become more adept at thinking about colours as you work, and more confident in predicting how a design will look when printed. This method of working is also possible when working with photographs or illustrations of thousands of colours. Essentially, you need to create a thumbnail image made of parts of a photograph at the same resolution as the original to get an idea of how the image will print. Sometimes this is not possible and you'll have to work with a smaller image than the original. Like with the palettes, each small thumbnail image can be altered using the colour tools to produce various colour options. You can also alter the cmyk levels, midtones, shadows and contrast, etc. The printed results help you understand how your printer deals with colour. Knowing how monitors create colour and how printers print colour, you should be more confident in your understanding of colour in the digital space. There's no magic solution to overcome all the variables of the hardware. Indeed, as new dyes and inks become available, printers using more than 4 primaries, such as hexachrome printers with high resolutions, become more affordable. Colour fidelity will improve, but will never be fixed due to the differences between additive and subtractive colour spaces and the reality of colour physics. Terms covered in this talk have been CIE LAB colour spaces, calibration, ICC colour profiles, bureaus, colour atlases, lookup books, and colour fidelity. I hope this has been helpful, and if it was, please recommend it to your colleagues and friends, and thank you for listening.